afternoon. I'm Hinojal Zazo from the University of Salamanca, and following I'm going to show you our results about the use of gold nanoparticles for targeting of stavudine to macrophages. This work has been done in collaboration with the RBTH Aachen University. And as everybody knows, HIV is a huge infection, and there are millions of people infected all over the world. According to the last report of WHO, it was more than 10 million of people, but thanks to the current therapy, the infection is controlled and the life expectancy is increasing. So if you can see in this chart on the left, according to that paper published in PLOS ONE, the life expectancy have increased more than 15 years since 2000. But the problem is, although the current therapy have a good control, it can eliminate the infection. The reason is because in this chart you can see the evolution of the viral load along the time since the initiation of the treatment. So you can see how the therapy can produce a deep decrease in the plasma HIV load. However, the HIV DNA load doesn't decrease so much. So the HIV RNA transcription to DNA continue in the body. The reason of that is because the antiretroviral drugs only target activated T cells, but there are other reservoir cells with lower virus production but longer cell longevity. So because drugs doesn't reach them successfully, these cells hamper the infection and even favor their spread. For that reason, and now we are going to focus on macrophages, which are the second virus production cells, and one of the most interesting HIV reservoirs. Thus, our objective is going to be to develop a drug delivery system, stavudine gold nanoparticles, to increase the antiretroviral drug concentration inside macrophages. To reach that objective, we have developed the stavudine gold nanoparticles, and to characterize them, we have used UV spectroscopy, dynamic light scattering, and ultra-pressure chromatography with UV spectroscopy. Secondly, human macrophages were isolated by fecal technique, and they were cultured during 24 hours with different concentration of gold nanoparticles and comparable concentration of free drug and drug coupled to the nanoparticles. To check the uptake and to quantify both nanoparticles and drug inside the cell, we have used different techniques like transmission electron microscopy, inductive plasma mass spectroscopy, and ultra-pressure chromatography UV spectroscopy. The results about the nanoparticles characterization show that the presence of stavudine coupled to the nanoparticles. Here you can see the UV visible scanning, which is the absorbance at different wavelengths. And we can see that the black dotted line, which is from naked nanoparticles, has only one peak around 520 nanometer, characteristic of gold nanoparticles, while the other one has another peak around 260 nanometer, characteristic of the stavudine. So that means that the stavudine is in the subspection, but we don't know if it's really coupled or not. So we measure the zeta potential, and that difference between around 35 millivolts corroborate the presence of the stavudine couple. So we quantified it by UPLC UV, and the loading efficacy was really high, around 70%. But the important thing here is not only the loading efficacy, because that is a percentage. The important thing is the real amount of drug, which is nearly 1 milligram, which is one of the highest amount of drug in comparison with other stavudine nanosystem. So after that, we incubated the macrophages with different concentration of gold nanoparticles. And in these optical microscopy pictures, we can see black points, which are the nanoparticles inside the cells. And only the highest concentration of gold was slightly toxic for the cells. The time analysis also corroborates the uptake, and we can see that they are all over the cell, and we can see endosomes inside the cells. To quantify that uptake, we use ICP-MS technique, and here we can see the amount of gold the percentage of gold per cell to each concentration of nanoparticles used. We can see that at 24 hours, the concentration uptake is a little low. It's only in the highest concentration is higher 50%. So that means that the uptake is a bit slow in comparison with the drug. Also, it's important to know that the percentage uptake is different between the lower to the highest concentration. So perhaps there is any way through the nanoparticles stimulate their own uptake by the cells when there is a high enough concentration. So our future research, our future studies are directed on to describe the kinetic of gold nanoparticles uptake by macrophages at different times, and when they reach the total amount of gold. After that, we incubate the gold nanoparticles, these 3 concentrations of gold nanoparticles, with the stavudine, and we use the comparable concentration of free stavudine to study and compare the uptake of the drug with or without carrier. And here we can see the UPLC-UV results. That is the percentage of stavudine by cell at the different concentration, the different comparable concentration of free drug in blue and with the carrier in gold. And we can see how the concentration is statistically higher when we use the carrier instead of the free drug. If we comparison this picture with before, this the uptake of gold nanoparticles is nearly 20%. However, the drug is higher than the 50%. So probably the reason of that is because the drug have a release from the nanoparticles. So we improve not only the drug release going to the cells by themselves, but also the drug which is coupled to the nanoparticles go into. So we improve that in the concentration inside the cells. So to sum up, gold nanoparticles are a promising nanotechnological strategy for targeting drugs to macrophages. And finally, I would like to thank both pharmacy and pharmaceutical technology area from the University of Salamanca and the Medicine Clinic 3 from the RBTH University, as well as the Spanish government for the financial support. And of course, thank you for your attention. If you have any consult art, you have my email. Thank you very much.
If I have time, 2 questions. First, how did you couple stavudine to gold nanoparticles?
We just incubate them at temperature, at high temperature, because if it's low temperature, nanoparticles aggregate.
No, you use the term coupling. So how is the gold nanoparticle interacting with your drug?
Yeah, it's a chemical bond.
Between what?
The gold and the drug.
Hmm? What is the bond between the gold and your drug?
Yeah, how?
Yeah.
Yeah, it's a chemical drug. It's between the nitrogen and the structure of the gold. And also
nitrogen is bound to gold?
Yeah, because gold nanoparticles also are stabilized by citrate. So the citrate also helps to... Yeah.
Well, you didn't show it.
I mean, yeah, that's true, sorry.
So the next question is, how is it being released?
That was a really good question because we don't know. In fact, the loading study, the drug loading study we have done indirectly because we can't cut the bond between the drug and the nanoparticles. So we don't know because the release, now we are doing the release study and depends on the temperature, the pH, it's different.
Okay, and then if I may ask a second question, I mean, maybe I'm asking now the wrong person because you are doing what you are supposed to do. I mean, for targeting, you have mentioned that gold nanoparticles is a nice new strategy for targeting macrophages.
Mm-hmm.
Liposomes, for the last 30 years, have proven to be an excellent carrier for targeting macrophages. Even commercially available technologies are out there which lead to the depletion of macrophages using liposomes. There are even companies out there who are producing and selling this. So my question to your advisor would be, why now gold nanoparticles? What's the advantage?
Yeah, because of the loading efficacy. With gold nanoparticles, we cannot...
I don't know argue now, but when you have to compare the loading efficiencies between liposomes and gold nanoparticles, and you have to show me that your gold nanoparticles are much more efficient.
Yeah.
Have you shown this?
Yeah, it's true, but...
No, you have not shown this.
Yeah, it's better with gold nanoparticles.
Where are the numbers? Comparison to liposomes?
Yeah, I don't have here, it's true. But loading efficacy, perhaps the loading, it's higher if you know, but...
No, I don't know.
Yeah.
No, I don't know. You have any idea how many drug molecules you can put into a liposome?
Yeah, you can. In fact, there are works about stavudine in liposomes and stavudine with polymeric nanoparticles, but the drug in this system is lower.
You need to show these numbers.
Yeah,
you need to show this.
Yes, sorry. Yes, I have. If you want, I can send you by mail. Yeah, I have the papers.
Is the gold nanoparticle is stable because your zeta potential looking the high and PDI is not given?
Yeah, it's a bit negatives, and sometimes they are. For that reason, it's important the temperature. At around normal temperature and around 20 or higher, they are stable, but lower temperature they aggregate.
What about PDI? Polyviscosity index?
We haven't studied the pH. No,
Yeah. Are they commercially bought citric capped nanoparticles? Are they commercially bought, or do you say that?
Yeah.
So you need to be careful because we do a lot of work with citric capped, but we make our own because there's a lot of batch to batch variation when you buy them in, which can affect the PDI. They can agglomerate together, which can affect the ability to load to load the drug and stuff like that. So just be aware if you don't get the same results each time, check the consistency of the batch.
Okay, we bought it because we were sure that it were always the same, and we thought that perhaps we bought it with more.
But they're not. They're definitely not. Anyway, we'll let you away now. Okay.
Thank you.
Thank you very much.
Thank you.
There's your certificate.